Hi everyone, my name is Xiaoyu Tongyang, and this video shows the demo of my funnel project. And a friendly reminder, this project is an individual funnel project, so the member is only me, and the goal of my funnel project is to visualize the triangulation algorithms. So it will has two parts. The first one is partitioning monotone polygons, and the second one is the triangulation. In other words, my funnel project will visualize both algorithms as well as the pursuit code. So let me talk over my funnel project web page with a few examples to illustrate my demo. As you can see, this is my funnel project web page, and this box is the canvas, so you can click on it to add points in counterclockwise order. In other words, in this direction and not this, and this is required. And the second box is this pursuit code box, and this box will show which pursuit code are being executed while the animation is showing the visualization. And the second part of the project page is this part. This part is the control part. You can import your polygons with these buttons, and also click on those buttons to see how the two algorithms work step by step. The final box is this instruction box. It will show some useful instructions while you are playing around with this final project. So let's talk with some examples to elaborate more on this. In summary, there are three ways to import your polygons. The first one is to add points on this canvas. So let's first do this. Assume we want to import this polygon, and we're adding points like this, and you can also delete those points with pressing the backspace keyboard. So like this, we deleted some points, and we add more points, and we assume we want to import this polygon into our program. When you are done, you click this Get Started button to import the data. Okay, as you can see, the program draw the polygon we want on the canvas, and notice the pursuit code box. It highlighted two lines. These two. It shows the algorithm or the program execute these two pursuit code. In other words, the program initialized two data structure. The first one is a priority queue, and the second one is a binary search tree, or balanced binary search tree, red black tree in our implementation. And then you can click those buttons to see how the two algorithms work step by step. So let's click on the next button, and you will see the animation for the sweep line. Okay, as you can see, and this time, the sweep line didn't appear out of nowhere. It moved from the top of the canvas to the place and the current vertex we're processing. And this green vertex is the one we're processing now. And also, in the pursuit code box, you noticed we went through those lines, this one and this one, which means the program executed this pursuit code during the animation. In other words, the algorithm check if the priority queue to see if it is empty or not. If it is not, it pop a vertex and process according to its type, and in this case it's a start vertex. And you can click those buttons to go through other steps, but I will not do this for this input method. I will do this for other methods. So the second way to import your data is through an input file. In other words, click here. So let's do this. First, let's reset our program to its initializing stage. Okay, and then import your input file. Let's say input this one, and then click Get Started button to run the program. And as you can see, the program draw the polygon, our old friend. This is the polygon we've seen many times so far. And then you can play around with this project as usual. This time we go through this by clicking those two buttons. So we first click next button to process our first vertex. This is a start vertex and a start vertex. And then this time is a merge vertex. And this time is a left regular vertex, and we added a diagonal. And then a right left vertex. And in the end vertex. At this point, we're done with the monotone polygons. So the next step, we will triangulate each monotone polygon. So let's do this. Click next button under the triangulation. We triangulate first polygon and this triangle, and as you can see, it is highlighted with gray. And next vertex and next vertex. And you may notice we have those red vertex and blue vertex. As I mentioned before in the previous presentation, red vertex are the one on the left chain, which is this chain. And the blue vertex are the ones on the right chain, which is this chain. So my program shows the status of a stack at each animation stage. So let's triangulate the next monotone polygon, which is this one. First vertex, next vertex, and next vertex. And next vertex, we added the two diagonals. And next vertex. And here we are done with our triangulation algorithm, and this is the resultant shape we have. So this is the way to import your file via an input file, but with this method I want to emphasize the format of input file. So let's first reset our program and go to a file, input file. Okay, as you can see, this is the file we just imported for the simple polygon we've seen. So the first thing you may notice is you are free to use line comments, the comment style like in C and Java, which like this. And the first line of this input file is the data for start vertex and end vertex, start vertex and end vertex. This data is to compute the shortest path in a simple polygon. But for the current implementation, and this feature isn't supported, so you are free to give random numbers like 4 zeros. It doesn't matter. And the second line is the data defining the visualization area, and it should be a square and should fully cover all given points. So what does this mean? Let's go to extra and to elaborate on this more clearly. As you can see, this is the example of trapezoid map, but the idea is the same. In other words, the data defining the visualization area is this rectangle, this one. As you can see, it covers all shapes in the inside the area, like this segment. In other words, the area you define should cover your polygon. Suppose this one, and the program will visualize the whole thing. So let's go back to our web page. And the next line is the number of vertices of the polygon, and the rest of the file is the data for each vertices. Each line represents a vertex with its x coordinates and y coordinates separated by a white space. And this is the format of the input file. So the second way, or the final way to import polygon is simply select an example from the example list. So let's do that. And as you can see, there are 3 examples you can select it from. A simple example, this is the one we just saw. And a complex example. This one is a little bit complex, and this one is also from the textbook. And the third example is a maze, which is a very complex. So let's deal with the complex example. And click Get Started button. And as you can see, we have this polygon on the canvas. So in this example, I will use this skip button to let the program automatically draw each animation for us. So let's first do partition monotone polygons. As you can see, the program automatically visualize or animate the whole algorithm for us. You don't need to click those buttons. And this is a merge vertex showing here, and a split vertex. So we added a diagonal, split vertex, added a diagonal, two end vertex, and left regular vertex, and left regular vertex, split vertex, added a diagonal, end vertex, and end vertex. At this point, we're done with the first algorithm, partitioning monotone polygons, and then we need triangulate each monotone polygon. First, we triangulate this triangle, but we'll do nothing. And then this polygon. And as you can see, the pursuit code is changed to the triangulation pursuit code. And then we triangulate this monotone polygon. Added a triangle, added a diagonal, another diagonal, a third diagonal. And then we triangulate this triangle, also do nothing. And finally, we will triangulate this polygon. Add a diagonal. Okay, at this point, you can see in this shape is the final result. Also, you can press the control button to switch between skip and reset buttons. If you click on this reset button, you will reset the program to the stage before one algorithm. So for example, if you click this reset button for triangulation, the program will be set to the stage before doing any triangulation. So as you can see, we go back to the status of partitioning or monotone polygons. So similarly, if you click the reset button for monotone polygons, it will go to the initializing stage. So we will do nothing to this shape. Okay, as you can see, the polygon becomes the original one, and you can partitioning monotone polygons and triangulate again. So I think this is my final project. You can play around with it and tell me if you have some advices or suggestions. So thank you for listening.